In this video, we're going to take a look at how to future-proof programs. Specifically, we're going to see how to program without using conditionals. And by conditionals, I mean if tests and switch case statements. Now, why is that important? There are two quotes I heard early on in my career that really kind of changed the way I thought about Java. These two quotes came from the same person right around the same day. One is, he said, if you're not using interfaces, you're only using half of Java's potential. The other quote, you can judge how well an object-oriented program is written by how few if tests it uses. In other words, the fewer if tests, the better. So this really changed my thinking around Java and object-oriented programming, and I didn't know what he meant when he said these two things to me because I realized I wasn't doing Java programming well. I was not using interfaces, and I was using an overabundance of if tests. And so after a while, I knew it would sink in, and after about 9 months, everything finally sank in, and I knew what he meant. And the way that I really learned this is I challenged myself to write programs without if tests. At first, it sounded really funny, because how can you write a program without an if test? But when I made that a challenge, and when I thought of different ways to write a program and different ways to make decisions without an if test, I realized what I meant. I realized that an if test oftentimes shows that you're putting logic into the wrong place. So, what's our challenge here? What are we going to do to demonstrate writing a program without if tests? Well, we are going to process a series of files that are deposited on a monthly basis. Here's an example from NetBeans. You see we have a directory, and in that directory we have annuity 01234, then employee 01237, so on and so forth. So the file name describes its contents. You see, an annuity is when a company, or an insurance company often, pays a beneficiary a given amount of money every single month. So in the annuity file, we have a first name and a last name and some kind of payment amount. So that's the format. It's the same format from one annuity file to another annuity file, even though they have different data inside. Now, what about an employee? Well, an employee wants to get paid at the end of the month. So notice for an employee, we have first name, last name, then we have a payroll amount, we have a bank, a routing and transit number, and an account number. Now, of course, I made up those numbers, just off the top of my head. So those aren't real routing and transit and account numbers. But nonetheless, you can see that we have first name, last name, payroll amount, bank, and then routing and transit and account number, which, while employee files have the same format between each other, the data is different. But then if we look at an annuity file, we see that annuity has a different format than the employee file has. You probably see where this is going. Life insurance means we're paying some amount of money to be insured every month. And if we take a look at life insurance, we'll see first name, last name, and then a payment amount, and then also a type of life insurance policy, whether it's term or whether it's whole life. So life insurance is going to be the same within that life insurance file. Different data, but same format. But the format is going to be different between life insurance and employee, and the format is going to be different between life insurance and annuity. So you see that the name of the file is doing some favor for us because it's describing the format that the file is going to have internally. So our job is we need to parse through this directory of files. There may be 0 files of any one type. There may be 1 file. There may be 25 files. They can be in any order. We'll find that it tends to alphabetize them based on our operating system, but it could really be in any order. So each file contains some information that the program needs to process some data. And the program has to be flexible because it has to understand that our business needs are going to change. And while we might process one type of file today, we might not process that type of file tomorrow. Or we might have new files that we need to process tomorrow, and we want to minimize the changes that we need to make to our application so that we can process these files. So we need to be future-proof. We need to think about the files that are going to come to us in the future that we don't even know about yet. And once again, we want to do all this without any kind of if test, without any kind of conditional. So what do we need? We need one of my favorite parts of programming, which is a concept called design patterns. I have a separate video where we're going to take a look at the design patterns that we're going to use in this series. We also need to use interfaces, a concept that we introduced recently in this video series, and now we get to see it applied in more depth. We also need another one of my favorite parts of the Java programming language, which is called reflection. We'll get more into this when we get into the example, but essentially reflection says, give me a string that represents a class name in Java, and I will return to you an object that I created from that class. Now, to read the data from our files, we need Java util scanner and Java IO file. And finally, we need the concept of loops. Now, this is interesting because if you've been following along this whole video series, there's nothing here that's really new except for the concept of patterns. Everything that we're looking at here are simply ingredients that we've seen previously in our previous videos. So reflection we've seen before, Java util scanner and file. We saw that when we were opening a file. Loops we've definitely seen many times. Interfaces we've seen just recently. So what we're doing with the design patterns is we're just seeing how to apply these different resources and make use of them. What we don't need, we know we don't need an if test, a switch statement, or a conditional. So I want you to think a little bit about the problem statement that I've given you with these files, and consider how you would design a program that would process these files. It's a good time to kind of pull out our friend Argo UML because we know that we can model classes here. If you're thinking you just have one class called something like runner and it does all the work, you're probably thinking the wrong way. But let's go back and let's take a look at what those files are. So we see annuity, and we know all annuities have the same format. It's going to be a first name, a last name, and an annuity payment amount. An employee is going to have a few more attributes, first name, last name, payroll amount, bank, routing, and transit. Life insurance is going to have some different attributes, first name, last name, the life insurance monthly amount, and then the type of policy. So if you're thinking that these are attributes of a class, you're on the right track. So you might start to think that we need a class that's going to process annuities, and we'll just call that annuity. And then you might think that we need a class that processes life insurance, and so we'll call that life insurance. And then you might think that we need a class that processes employees as well. So we can make that. We can make an employee class. Okay, now we will still need our runner class, but we're going to need some way that we can associate all of these three classes together and have them affiliated with the runner class. So these classes are very different. An annuity represents an amount the company is paying to its customers. Life insurance represents an amount it's billing its customers. An employee represents an amount that the employees are getting paid at the end of the month. So we can't make a superclass for all three of these together because they just don't have anything in common. But here's something that we can do. We can tie them together with an interface because remember, a class can implement as many interfaces as it wants. So we could give this something like monthly item, just to indicate that each of these are a different monthly item that needs to get processed. We could give it an operation. So we go here, we go to, we go to new operation. In this operation, we can say something like execute, and it might accept a file or something like that. And then what we can do is we can use our dashed line to indicate that each of these classes implements the interface execute. And then we can use a solid line to indicate that the runner class uses a relationship with monthly item. Now there are a few more things that we have to go here. We also need to think about some kind of factory, abstract factory, which either could be part of this runner or could be separate. We also need to think about what is common across all of these subclasses. For example, life insurance and employee, life insurance and annuity, those are both customers, where an employee is not necessarily a customer. So we could have a superclass across both annuity and life insurance, but not employee. So there are even more things that we can think about, but this is enough to get us started in how we're going to approach this problem. So lots of work in runner. If you think about our previous classes, that would be something like driver or converter runner, or our banker class from our assignment. And then this would be like our checking, savings, and CD classes. Could also be like our Prius, Cavalier, and Neon classes, depending on the example. So this is something that we've been building up to all semester, and I think this is a good time to take a look at it. So in our next lecture, we're going to talk a little bit about design patterns. I look forward to seeing you then. Thank you.